I have a feeling this is gonna be, yeah, this is gonna be totally shit. There are two things software engineers usually say. No code ever is flawless without a bug. The second thing we always say, usually after fixing about 7 bugs in our own code, is that it's bug-free, now it has to be done. Well, let's see if today I'll be able to write bug-free code. We're going with data flowers. This is the red path, phase 4 of the game. So I expect some clever new mechanics. We've got a new command for each direction probably, so we can quickly scan each of the 8 tiles around each worker. And this manager suggested the command would be called sit and spin. I mean, it's not a bad idea to call it that. So what we need to do is sum the numbers in each of these flowers and write their sum in the center. So first I would say pick up the cube that's under you, and then each of them needs to walk up into the center of these 5 flowers. So for each direction, what does it do? Okay, I can deselect a few. Alright, so I'm gonna this time use this, question mark. Tell me what this freaking command does. Repeat for up to each of the 8 directions. The contents will be placed into a memory slot. Okay, I see. So this is just to save a few commands, where that's usually what a for each is. But usually a for each is used when you don't know the amount of elements. I could technically just have like 8 commands. Let's first make them step into the flowers. So remove that, and everyone is gonna be stepping up, and if under you there is a data cube, I would say, and there's a data cube above you, but under you, yeah, once a data cube is under you, then you're done. So if a data cube, I said under you, are you stupid? Is a data cube, then you're done. So let's say if there isn't a data cube, you repeat. So that means all of them are within these circle squares, and then for each direction, S memory 1, I'm confused by the S, but basically look into each direction and every time store that in memory 2, and every time you're gonna calculate in memory 1, that's gonna be the sum, memory 1 plus memory 2. So basically sum up the elements. Then you're gonna write the result on your cube, and the result is memory 1, and you're gonna drop the cube. I think that's it. So pick up the cubes, keep walking. These people, yeah, they started calculating, so 1 plus 3, 4 plus 3, yeah, it seems to be working just fine, so speed this up. Then eventually they write the numbers, and that's it. 8 commands used, 8 needed, 24 seconds, 25 needed. Well, that was easy. So come on, this was bug-free, yeah? New level, new tasks. Pick up the maximum out of these flowers and shred them. Easy enough. I think everyone should be able to take 2 steps to the left. And then let's do for each of the cubes, store them in memory 2. If the cube in memory 2, that is the number, is larger or equal to what's in memory 1, I haven't initialized memory 1. I didn't want to do it because I don't have to. I want to leave it at 0 as it was. But to use it here, I have to do that. So once it's larger or equal to, we remember it. So set memory 1 to memory 2. There, easy. The reason I use equal to is because memory 1 is initialized at 0. And there might be a cube 0. All of them might be 0. But I need to pick one up, right? I would like to initialize it at -1, but I can't. So they've done this, and then you basically just pick up what's in memory 1, that should be the cube, the largest cube, and then you go to the nearest shredder, which is gonna be in memory 3, because this time I am just not gonna use the same memory over and over, and shred the cube, meaning give to memory 3, the shredder. I mean, sometimes I do reuse memory here in this game, but it's such a dumb, idea in real life. Just imagine if you had like an integer called sum, then you used it in your code, and later you would say, all right, I'm no longer gonna use it, I might just as well reuse it. So now I'm gonna store the count of something in that variable. So it's still gonna be called sum, but it's now a counter. How stupid. Anyway, how have they picked up so quickly? What the shit? Wait, that's not possible, is it? What? 13 seconds, alright. I don't get it. Step by step, user. Step, yes, okay. So far so good. And now, I would say that you look in each direction and execute the if statement. If you set, yeah, he does that, but he basically does it instantly. What? I mean, is it just because an if statement in this game is pretty fast? That might be it. But come on, I would say it was even too fast. Alright, now we need to remove a single command. How do I do that? Oh boy. I don't know. I don't know. I think I shouldn't set memory 1 to anything. Why does it suddenly work? Let's try that. Still works. Alright. But here I'm unable... Okay, I'm now able to select memory 1. I deselect it and it's still there. Oh, maybe because it's now here. So if I remove this, let's say a wall there. Why does it suddenly work? Oh, pick up memory 1. So I need to remove any... Oh, right there you see. No memory 1. So this is like cheating. But once I say pick up memory, still doesn't exist. Memory 1 doesn't exist. Here I can say set memory 1 to memory 2. Now I can say pick up memory 1 because now it exists. And here, once this if statement is reached, memory 1 shouldn't exist yet. But it allows me to select it now. Because in-game it technically exists with a value of 0. But this menu just wouldn't let me select it. Alright, so that's it, completed. Both optional challenges done. Great. This is a pretty good streak. Let's try one more. I have a feeling this is gonna be... Yeah, this is gonna be totally shit. For each cube below, record how many neighbors it has in the 8 adjacent tiles. Write that number on that cube. Alright, that seems quite simple. Now I see that the problem is that the if command sees data cubes only if they are on the floor. And if you try to query a tile that contains a worker who is holding the cube, the if command does not report as having a cube. So this area here might be an issue, since this lady might be holding the cube and this guy wouldn't see it, basically. Let's first try it and then see where the issues are and then fix them. So each of them is going to have to be stepping in different directions. So if to the left of you there is a wall, you're going to be stepping right, and the people on the right side are going to be stepping left. So you're stepping right there. Why is there 2 already? Is this going to be the only issue spot? Why is there 2? What the shit? Now the dumb way to do this is to have 2 blocks of code which are the same. Because again, I don't remember how to make like half of the people go right, half of the people go left. Let's just write it for the people on the left side first. So no if statement for now. I'm gonna say if there's a wall to the right, you end your program. So the people on the left, step right. If you are standing on a data cube, you need to calculate how many cubes there are around you. So for each data cube, store it in memory 2 and set memory 1 to... No, I mean calculate in memory 1 what's memory 1 plus 1. This is a little dumb, isn't it? But I mean, it has to be like that. I just don't care what's in memory 2, basically. Pick up the data cube, write your number on that, so into memory 1 you write that, and you drop the data cube. Once you've done that, you jump back here, take another step, and repeat the process. But in memory 1, you're still gonna have this number, so probably you want to reset it after you're done with it and you've written stuff, so set to 0. This should work for the people on the left side. They're computing already and it doesn't work. So this person wrote 8, they basically all have written 8. Right here I have to say, not for each direction, but if there is a data cube, only then you increment. So if in memory 2 there is a data cube, you increment. Right, let's try again. 1, 1, 2. Alright, this works. Yeah, I think this works. This should be fine. What I'm gonna do is use memory 3 as an indicator on which side they are actually standing right now. So if to the right of you there is a wall, you set memory 3 to 0, or let's say to 1. Otherwise, you're on the left side and it's on 0. Here, where you take a step, I'm gonna say if in memory 3 there is a 0, you step right, because you are starting on the left. Otherwise, you step left. So you're on the right side, you set 1. And now they can all have fun. And then we're gonna see where the issues are of them calculating not properly. But I have to kill it in time, because then I'm gonna get a huge message telling me that I screwed up. Alright, there. So, I expect the issues to be somewhere in the middle. Let's just quickly run through it. I think no issues here. 4. That's 4, 4, 3. Are there any issues? 6. That's 8 minus 2, 7. Sure, 8. 5, 5. It works. What's your problem? Why did they tell me that there might be an issue? I'm just gonna let it finish and we'll see. Yeah, it works. What do you mean? And, oh, we've only used 15 commands? Wow. So was I smarter than the intended solution? I love this. I mean, I'm not in love with the command. I think the tell and listen stuff is a little smarter. But this is fun. Actually, I would say that might be the only thing that makes coding fun. When you get it right. And I did get it right, so happy me.